How to graph y equals cosecant x. So what goes with cosecant? Sine. That's going to be our first step, is to graph the sine function that goes directly with whatever cosecant function we're supposed to be doing. Since there's nothing in front here and nothing in front of this x, our amplitude for sine will be 1 and our period for sine will be 2 pi, because it'd be 2 pi over 1, which is 2 pi. So we make our x and our y-axis. We go out to 2 pi and out to negative 2 pi. We're going to go up to 1, down to negative 1. We're going to make a mark halfway, 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 because that's how we have talked about how to graph sine. Sine starts at 0, and if it's positive, it goes up, and then it goes back to the middle, then it goes down, then it goes back to the middle. We can continue the pattern to the left as well. But see, we've got this nice sine-like graph. And we draw this kind of lightly or like a dotted line or something, because this isn't the real graph. This is just going to help us get our real graph of cosecant. Everywhere that we cross the x-axis, we need a vertical asymptote. Okay, so all of those places I just put a dot, I am drawing a vertical asymptote. Oh, got a little unvertical there. That's a little better. Okay, and then we finish off by, at the top of each of these, we draw a U shape going up. At the bottom, a U shape going down. Up, down. And that's our cosecant graph, the part with the U shapes. Now for our vertical asymptotes, we pick an asymptote like, let's say 0, or we could pick here in the middle is pi, or just we could pick 2 pi. We pick one of them, and then we add to that how often are we going to have an asymptote. Well, the period is 2 pi, and just like if you watched the secant video, the asymptotes are going to happen twice each period. So they're happening, and it's pretty easy to see for this, they're happening pi apart. So we need to put that our asymptotes are at 0 plus pi k, or any other asymptote we could pick and use something plus pi k, where k is an element of, that's terrible. Why did I even bother trying to fix that? K is an element of the integers. Now let's try to get a little bit crazy with this, but in a safe mathematical way. Let's try to graph y equals 1/2 cosecant of 3x. So we always need to start by thinking of this as its reciprocal function. Okay, and notice the 1/2 and the 3 get carried into it. We don't just graph sine x, we graph 1/2 sine 3x. The amplitude of this sine function is 1/2. The period is going to be 2 pi over 3. Okay, this is a, well, whichever way you look at it, this is a horizontal shrink by 1/3. We also have a vertical shrink by 1/2. That's the transformations going on. And so when we graph this sine function, we're not going to go up as far as we did the first time, like compared to the other graph. And we're also going to be closer to the x-axis. So we draw our x and our y-axis. And if you know, like if this was 1, say, if that was the case, then we would have to only go up halfway and halfway, or up and down halfway. And then we can make a mark out here for 2 pi over 3, and a mark out here for negative 2 pi over 3. If we make a mark halfway on each of these, and we wanted to label it, halfway between 0 and 2 pi over 3 is going to be pi over 3. Okay, because the pi over 3 and then 2 pi over 3. Make a mark halfway and halfway. Halfway, halfway. And we're ready to draw our sine function. So we start sine at 0. It's a positive sign, so we go up. So notice I'm only going up to 1/2 and down to 1/2, not all the way to where I drew 1, which you could just make a mark and put and label it a 1/2 and that would be fine. I was trying to be like a little more adventurous, I guess you could say. Here is my sine curve. Now everywhere that we go through the x-axis, we need a vertical asymptote. Everywhere that we have a low point, we need to put a down U, and every high point, we need an upward U. And let's talk about our vertical asymptotes. Our vertical asymptotes are happening at x equals, we can pick 0 is one of them. And then how far apart are these asymptotes? Well, they happen twice a period, so you can take 2 pi over 3 and times it by 1/2, which is pi over 3. Or you can look at this and say, well, there's one at 0, there's one at pi over 3. Those are pi over 3 apart. So 0 plus pi over 3k, where k is an element of the integers. And that is cosecant.